Hello and welcome to the fourth notes in the chapter on rhombi and squares. So a rhombus, which is the singular form of rhombi, is a parallelogram with four congruent sides. So like I said, plural form is rhombi. So let's go ahead and mark this with its definition. It has four congruent sides. Because it's a parallelogram, obviously opposite sides are going to be congruent. So a rhombus will have all the properties of a parallelogram, and we are going to determine the other properties. The title here says draw the diagonals, so they're drawn in here in pink. What are the four congruent triangles? So we know that the four sides are congruent. We know that because this is a parallelogram, the diagonals bisect each other. So BD gets bisected, it gets split in half by AC, and then AC gets split in half by BD. So why are the four triangles congruent? What's the reason? Is it side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg? In this case, it's side, side, side. All right, so we're going to use CP/CTC, and then we know then that the angles here, like this little angle by A, let me erase that and make it better. This one is congruent to this one, is congruent to this one, is congruent to this one, because those are the angles between the single tick mark side and triple. This angle is congruent to this angle, is congruent to this angle, is congruent to this angle. Again, those are between the single tick mark that I have and the double. And then this angle here has to be congruent to this angle here. Because these two angles together are a linear pair, they add up to 180. Because they have to, sorry, I just got off the tape. Because they have to equal each other, that means they have to be 90 degrees. So every one of the angles here whose vertex is P is going to be a 90-degree angle. So that gives us our two extra properties. The diagonals of a rhombus are perpendicular, and then this one, each diagonal bisects an opposite pair of angles. So remember, because this is a parallelogram, angle A was congruent to angle C. That was always going to be true. This angle is congruent to this one. So now because the top piece of it, meaning like right here, and the bottom piece of it, because they're congruent, that means that diagonal bisected that angle. It split it into two equal pieces. And then the same is going to be true for angle B and D. Angle B was always going to be congruent to angle D, but now we see that the diagonal, because this is congruent to this, that means that the diagonal bisected that angle, aka split it into two equal angles. So on this slide, we're just going to go ahead and reiterate those two properties. Given that you have a rhombus, the diagonal here, RM, is going to be perpendicular to BH. So this is always going to have right angles. And then angle 1 is congruent to 2, congruent to 3, congruent to 4. Those get bisected, but they were equal to each other, so therefore they have to all four be equal. And then angle B is congruent to angle H. Those were originally going to be congruent to each other because it's a parallelogram, but now when we draw on that diagonal, we've made all four of those angles congruent. Again, that's not going to be true for just a regular parallelogram. If this is 70 degrees and I draw in that diagonal, there's nothing that says that that gets split in half, okay? That's only true if we're dealing with a rhombus for now, until we get into a different type of rhombus in a second. First example here says, if the diagonals of rhombus WXYZ intersect at V, and the measure of WZX, so that's going to be this angle right here, is 39.5, we are going to want to find the measure of ZYX. So that is going to be this entire angle. Okay, so if we know that WZX up here is 39.5, this bottom angle is going to be also 39.5 because this is a rhombus. Together, when I add these, they're going to add up to 79 degrees. We know, because this is a parallelogram, that consecutive angles are supplementary, which means angle ZYX plus 79 degrees has to equal 180 degrees because they're supplements. I subtract 79 degrees from both sides and I get the measure of angle ZYX is going to be 81, just kidding, 101. 101 degrees. Next problem, it says the diagonals of rhombus WXYZ intersect at V, and WX is 8x minus 5. WZ is 6x plus 3, find x. Because this is a rhombus, all four sides are congruent, so I know that 6x plus 3 is going to equal 8x minus 5. I'm going to solve for x, add 5 to both sides. I get 8, or 6x plus 8 equals 8x. Subtract 6x, we get 8 equals 2x. Divide by 2, x is going to equal 4. So let's see what they wanted me to find. Just x. Remember, I could plug this in and make sure that I found this correctly, because if I plug it in for x here, 3 times 4 is 32. 32 minus 5 is 27. And if I plug 4 in here, I get 24. 6 times 4 is 24, plus 3 gives me 27. So I could be pretty certain that I found the correct value, because this is a rhombus, so the sides have to be equal. This next theorem here says if we have one pair of consecutive sides, consecutive meaning next to each other, so like what we have here, these two sides, consecutive, are congruent in a parallelogram, then the parallelogram has to be a rhombus. Remember, opposite sides of a parallelogram are congruent. So if this is a 1 tick, this is going to be a 1 tick, and the same holds true for the left and right side. In this case, that's also going to be a 1 tick. So because opposite sides are congruent, that makes all four sides congruent. So how can we use this to prove that a quadrilateral is a rhombus? Well, when you do distance formula, once you know that you have a parallelogram, let's say you find that this side is square root of 5 and this side is the square root of 5, then you know the opposite side here has to be square root of 5 if we know it's a parallelogram, and the opposite side here would have to be square root of 5 for that same reason, because opposite sides are congruent in parallelograms. Okay, so next we're going to talk about the most perfect quadrilateral, the most specific specialized one, and that is the square. And so if a quadrilateral is both a rectangle and a rhombus, then it's a square. So if we think about this, and if we relate it to animals, like dogs, for example, a golden retriever and a poodle, when you mix them together, is a very popular breed called the golden doodle, right? It's a golden retriever and it's a poodle. So that's what a square is. It's a golden doodle. No, I'm just kidding. But you could think of it that same way, that it gets some of its identity from a rectangle, and then it gets some of its identity from a rhombus, so then it becomes a more specialized, unique shape, I guess. So what we're going to do is list all of the facts that we know about sides, diagonals, and angles of a square. I'm going to write down a bunch of properties, and they're going to be all the ones we've learned and where they came from. So it's going to pop up suddenly, and when it does, please pause the video and write them down. So the first thing I wrote down is that a square has 4 sides and its angles sum up to 360 degrees. It gets it from the fact that it is a quadrilateral. That's where it gets these two properties. Next, I'm going to list all the parallelogram ones. Here's our next set of properties that a square has. Opposite sides are both parallel and congruent. Opposite angles are congruent. The diagonals bisect each other, and consecutive angles are supplementary. And a square gets this all from the parallelogram. So if you think back to the quad tree, everything trickles down the branches. So because a square is underneath the branch of quadrilateral, parallelogram, it has all those properties. Next two properties, it's going to have 4 congruent angles, each being 90 degrees, obviously, and then the diagonals are congruent, and the square gets this from the rectangle. Because a square is a rectangle, it's going to have these properties. All right, so the last of the properties that a square has is that it has 4 congruent sides, the diagonals are perpendicular, and the diagonals bisect opposite angles. It gets all of those properties from the rhombus. So the square is what I always refer to as the most perfected parallelogram. It has all the properties of all the parallelograms above it, and yeah, it's the perfect parallelogram. Here we have a summary of parallelograms and how they relate to each other. So you notice the outside circle is all parallelograms. They're all in there. Rectangles and rhombuses are a smaller subset of them, and where they intersect, that's where we get our squares. So a square is a rhombus, is a rectangle, is a parallelogram. A rectangle is a parallelogram. A rectangle might also be a rhombus if it's a square. So that's where this gets kind of confusing with the always, sometimes, nevers that I've been telling you about and warning you about for the last few weeks. All right, so the way that we could prove that a quadrilateral is a rhombus, you could show that it's a parallelogram with perpendicular diagonals. You could show that it's a parallelogram with a pair of consecutive sides that are congruent, consecutive being next to each other. Or you could show that all four sides are congruent. So again, here, perpendicular diagonals, to find if diagonals are perpendicular, you would find the slopes. So you would calculate the slope of each diagonal, and if they are perpendicular, you're going to get opposite reciprocals. Okay, to show that the sides are congruent, you would do a distance formula, and you would do two sides that are next to each other. That's what consecutive means, so not the ones across from each other, but next to each other. Or you can show that all four sides are congruent, so again, that would be, one more time, distance formula, 4 times. So when you're starting off, if you aren't sure, just find all 4 side lengths, and then if they're all the same, you know it's either a rhombus or a square. And so here, to prove that it's a square, how we would do that, you would show that it's a parallelogram with perpendicular and congruent diagonals. You could show that it's a parallelogram with a pair of consecutive sides that are congruent and perpendicular, or you could show that all 4 sides are congruent and a pair of consecutive sides are perpendicular, so 90-degree angles in the corners. So it's always going to have to be more than just going through one time like we did with just parallelograms. We could just find the 4 side lengths and that was good enough. Now we're going to have to go deeper. We're going to prove that it's a parallelogram and then some more stuff. When I begin these problems, I always like to write all the shapes that it could potentially be. We're going to add more when we start studying kites and trapezoids, but for now it could be a quadrilateral, parallelogram, a rectangle, rhombus, or square. Okay, so we are going to see which one it is. So I would, looking at it, you're not always going to have it graphed, and you're not always going to have a piece of graph paper, because if you just go based on the looks and you don't show the math behind it, then you're not going to get points for it. Okay, so here's what I'm going to do. I'm going to find the slope of each of these sides. So I'm going to count, I'm going to do my rise over run and count how what the rise and run are. So up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7. All right, so the slope of AB is 6/7. Over here, the slope of BC, I'm going to do the same thing. It's down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. This is -2 over 9. And just let me make sure that my B was correct. Yeah, it was. Okay, now I'm going to find the slope of CD. And it's down 1, 2, 3, 4, 5, 6. And to the left 7, so it's 6/7. And then over here, the slope is also -2 over 9. Okay, so what I've shown so far is that this is a parallelogram because I've shown that both pairs of opposite sides are parallel. I can also eliminate other choices right now. Consecutive sides, if this was a square or a rectangle, because those have 90-degree angles, consecutive sides, meaning like AB and either AD or BC, whichever, if this was a 90-degree angle occurring right here, those would be opposite reciprocals. So this means these slopes show that there are no right angles. So I know it's not a rectangle, I know it's not a rhombus, and I know it's a parallelogram. I'm sorry, I know it's not a rectangle, it's not a square, because those have 90-degree angles. It's either a rhombus or just a plain old parallelogram. So here's what I will do to prove that it's a rhombus. I could either prove that the diagonals are perpendicular. That would make it a rhombus. It's more specialized than just a parallelogram. Or I could check 2 consecutive sides, their lengths, and see if they're the same. So I'm a fan of lengths. So I'm going to find the length of AB. I'm going to find the length of, and I don't have to, if I find the length of AB, I already know, because it's for sure a parallelogram, that CD is the same length. So I don't have to do a distance formula for both of those opposite sides. I only have to do it for AB. And then I know that AD is congruent to BC because we know this is a parallelogram. So I don't have to do 4 times the distance. I just have to do it twice. All right, so let's find the distance between A and B. So from 7 to 0, negative 7 to 0 is the distance of 7 squared, plus negative 2 to 4 is a distance of 6 squared. So I would get the square root of 49 plus 36. This is going to equal the square root of 85. Okay, so I know automatically this one has to be the square root of 85 because I know it's a parallelogram. So now I'm going to do the same thing for AD. From A to D, negative 7 to 2 is a distance of 9 squared, plus negative 4 to negative 2 is a distance of 2 squared. So I get the square root of 81 plus 4. That is equal to the square root of 85. Okay, so what I've just shown, if this side is square root of 85 and this side is the square root of 85, then all the sides are square root of 85. All right, so it's a rhombus. And my description would be as follows. I would write ABCD is a rhombus because it has 4 congruent sides. But now wait, that could be a square, so I have to say, but it doesn't have 4 congruent angles. So in the beginning of this problem, if I hadn't done slopes, if I did distances and I got all 4 sides were congruent, I would then know I'm either dealing with a rhombus or a square. And so then you have to do one extra thing to show whether or not it's a square. So you would check for 90-degree angles or congruent diagonals, a property of a square that it gets from the rectangle. So here, I knew it was either a rhombus or a parallelogram, so you always check the more specific shapes properties. The reason for that is a rhombus has all the properties of a parallelogram, so it would make no sense for me to check, do the diagonals bisect, because that happens both parallelogram and rhombus. So you have to check a rhombus's properties because a rhombus is going to have certain things that a generic parallelogram won't. Okay, and we'll practice these a lot, and it gets better, and the descriptions become a little bit easier, I think. All right, so ending with a joke today. What do horses say when they fall? Help, I've fallen and can't giddy up. Ha ha. Okay, so in class we're going to work on the chapter 6, day 5. I don't know if these numbers match up anymore. I'll let you know when we see each other, but it's also just going to be labeled rhombi and squares practice. All right, thank you so much for watching. Have a great day. Bye.